Okay, I guess we're live. We've got
Woo.
Tara
Hello.
and we're sort of at the last mile for a 03.
You say sort of because of the other issue you weren't sure about, the service worker stuff?
A whole bunch of things. So I did get the service worker thing fixed.
That's great.
Well, yeah, because it's an issue I ran into before with the old Wanix, and then talking with Claude, the solution was pretty simple.
Oh, yeah, you did message me about that. Well, that's amazing.
So I could show the service worker thing, but then I realized we had been experimenting with using BigGo to compile, since it has better kind of debug stack traces. But then the problem is that you don't know if you introduce a library that doesn't work with TinyGo. So actually, yeah, we were. It turns out that there is a tiny thing in the implementation that doesn't work with TinyGo.
But it's tiny.
Let's see. Oh, I disabled it. So let's see. I'm trying to make WASM. Okay, this is another problem. There's like bunch of things going on here. TinyGo build. It claims to have built it. Let's see, that's because I commented out the service worker stuff. So it's kind of funny that there's still stuff in net HTTP that doesn't work in TinyGo. But specifically this, I guess that's where it's importing in. But I'm using like one thing from that library that I probably don't need to. So I'm wondering if that will fix that. Let's see.
Yeah, that would be nice and easy.
So what this does is it creates a normally when you make a HTTP handler, it hands you the request, so you can look at the request, and it gives you something called a response writer that you can call write and set headers on. So it's basically like the output, and normally it would write it to the network connection, but you can use this response recorder thing because it implements the same response writer interface. So it's basically going to record the response and then you can inspect it. So it's just a little stub that lets you kind of record the response instead of actually writing out a response to any network, and then that way we can I'll explain what's going on here in a minute, but I'm trying to think if there's a quick way I can replace this with something that implements the right interface. Oops.
Did you, I mean, tangentially, did you happen to see if there's like a feature request for that for TinyGo or anything?
Oh, it's a known issue. It's like, I don't know when they're finally going to get to. I have no idea what their roadmap is, or priorities, or contributors, what all the hell they're doing. It actually, like, one of the instigators for this whole rewrite is that because duplex, which I use all over the place, it uses CBOR, which is like a binary JSON format. And for the longest time, CBOR didn't work in TinyGo. And then finally they fixed the one thing that was missing. And so we could use CBOR. And so that kind of opened up this whole TinyGo thing. But of course, there's other possible places where we might depend on something that isn't supported yet. Which is a little bit of
a mouse a cookie.
What's that?
I said if you give a mouse a cookie.
Yeah, I've never heard that expression.
What? Are you joking?
Give a mouse a cookie.
Oh, you haven't really? Okay, well, it's from a book. If you give a mouse a cookie, he'll want a glass of milk. And if you give him a glass of milk, he'll want, just like this long list of, yeah.
I mean, I've kind of inferred that, but I don't think I'd heard that explicit thing before.
I think of it all the time in product stuff.
Yeah, it applies to me a lot. Let's see if I can get AI to generate, let's see, what is it? I mean, I'm pretty close to just copying and pasting the code, because it's not that this doesn't work, it's that this package likely depends on something that depends on something that's not supported. That's kind of the game here. Actually, if that is the case, maybe I can just grab an implementation here, response recorder. Yeah, and then HDB guts. I'm gonna see what happens. Hopefully this is everything for that. Do we have an internal? We have external. Oh, no, put it in the right place. What's the problem here? What is this even used for? Valid trailer header. Oh, nobody uses trailers.
What the hell is that?
I think when you do an HTTP request and you do, there's a mode where you can stream the response in chunks. And I think there's a way to specify a trailer chunk, which it's supposed to be the opposite of a header. It's like header data, but it comes later.
But people don't use it, you said?
It's pretty rare. Like, I ran into it in a career of doing HTTP only once and ended up not even using it. So I wonder what their trailer prefix. This all has to do with trailer stuff. What if I got rid of it all? Why are they putting all this stuff in the trailer? Okay, so now it doesn't have that dependency. Response recorder, new recorder. All right, now we gotta try using this instead. Oops. I think that's right. Build. Okay, it worked. So that strategy at least made it compile.
Nice.
Yeah, I'm pretty sure it was that package that was only used for that one aspect. So yeah, we pulled in some BSD code here. Let's leave this copyright in there. Yes. Yeah. Okay, so now I could actually at least show the service worker stuff working. Hopefully. Man, a lot of stuff is changed.
That's our last stream.
Yeah, potentially. Was there? Let's see. Yeah, a lot of cool stuff. So the JavaScript Wanix class takes a config, although I don't use it yet. Really, it was set up a little different because there isn't a good way to communicate or share data between your Go WASM and JavaScript. Really, the easiest thing is to, from your Go, like use the global object to access something off of window. And so basically sharing global state, which is not ideal, but I sort of set up a convention. Okay, there will be a global called Wanix, and then that's basically a container object for anything that we might want to share between them or have a reference to. So when you create an instance of Wanix, it actually creates, puts a reference to it under Wanix instance. So you can only have one Wanix instance on a page for now. And then there's just a couple of other things in here that are picked up by the WASM stuff. I also split out all the file system stuff on this that communicates over duplex into a class called Wanix FS because of some worker stuff that I'll show in a bit. Basically using this as a library in some JavaScript that you want to run as a worker. This gives you an API to the file system from that worker. You don't really need to create a new instance of the Wanix kernel, so you just need a way to talk to the file system. Anyway, so let's see. This was cleaned up. Where was I trying to get to? The service worker stuff. Let's see. You've seen this before. This is the service worker. All it does is when there's a fetch, it will try and send that request off to whoever's registered as a listener, and they can send back a response. And if you don't get a response within a second, it just does a normal fetch for the resource. Or if 100 is returned, it does a normal fetch. So this has to be registered, and before I was registering it in the Wanix class, but now it's sort of built into the core Wanix kernel stuff. So this context is now basically a pointer to this object that has all this shared stuff. So in a way, I made the service worker stuff optional. If I didn't set service worker, if I didn't create a message channel for it, it won't try to set up a service worker. But basically here it's setting up the web, file system and stuff, and it sets up DOM, VM worker, and then only if SW is defined in the context do we set up SW, which is set up with this activate thing in the actual service worker package. And activate does what we were doing before in JavaScript, so now it's a lot uglier. Although I made a little helper here that lets you at least do these like dot paths instead of saying get navigator, get service worker, get whatever. I can at least do this. Anyway, it checks, hey, is get, registration, is there a service worker registered? If it's not, then it registers the service worker, waits till it's ready. Either way, it then sets up the device with a pointer to the active service worker. This is, I guess this is the other end of the message channel that's registered as a listener. Oh yeah, it is.
You guess.
Because we call post message to the service worker, give it a message channel port that is going to be the listener. So this is where it's going to send all of the HTTP requests. And then this is sort of the other end of it. And we set the on message handler. So any messages, any of the requests that sends through here is going to be handled by handle message, which is down here. And this was actually the thing that we had to fix to avoid the deadlock, was running this in a Go routine. So kind of having this split off as like an asynchronous thing kind of allowed these two paths so they don't get what is the word? a circular dependency on these code paths. So that was causing the deadlock, and just wrapping this, making this asynchronous fixes that. But anyway, most of all this code is doing is getting the request and getting all the JavaScript stuff, using the JavaScript, request to create what looks like an HTTP request in Go. Then here's that recorder that will record the response. Then we do serve HTTP. Whatever the response that was created, we then send back as a post message. Anyway, this is not new, but it's fixed. And then here's the actual serve HTTP, in which case we pretty much always return status continue. So more or less always serve stuff over the network, unless the URL starts with /sw. If it does, then we pull SW off of the path, and we do a read file on the kernel root namespace, and we write that file out. So basically it's letting us load files from the file system over HTTP via this service worker. That is the goal here.
Cool.
Which does work if I can remember how to make things work. I don't know why it's... I mean, it always took a little bit longer, but I wonder why it's taking longer now. All right, 80. Oh, I switched. Wait, I forgot. We need to make this switch. It'd be good to automate this. All right, service worker installed. Thanks for letting us know. So that's saying, because the service worker is running as a web worker that continues to run even when, like, even if you navigate away, I think. So when you come back to the page, the service worker is still the same instance. It's like one of the only kind of persistent things on the web. Usually everything is, loaded completely from scratch when you, except for, storage or whatever. But anyway, so this is telling us that we installed a listener, a handler to the service worker that's been registered. If we reload again, because the service worker has the listener from last time, which is a page that doesn't exist anymore because we reloaded. It tries to send a request out to it, and it times out after a second. And so that's why we get this error. And it's set up so that if you get a timeout error, it uninstalls the listener. But then the page loads, because it's basically these are coming from trying to load the resources for the page. And then once the page is loaded, then it installs a new listener. So it's kind of a weird, I'm not sure the best way to express this, because it's not really an error. But it's good to know that the service worker is working sort of as intended, even though this is a confusing... You have to know how the service worker stuff works to know that this is not a problem. Anyway, service workers installed. What does that mean? I don't know. It means we've got a /sw. I don't think there's really anything interesting it does here. We can get the state of the service worker. The control node, I was going to try and see if I could just do an enable and disable. But I was thinking if you were to mount a path in here called root, then that's what it would use to serve requests. And then that way you can you have a dedicated path to set up what you want to be served by the service worker.
Mm-hmm. And it's like familiar.
Yeah. For now, it's just sort of hard-coded to pass through unless something starts with SW, and then you're able to reference stuff in our file system, DOM, whatever. So, for example, I guess we could read web, if I can type service worker state activated. Okay, so we should be able to read this file with fetch. Service worker web, service worker state, and then await our text activated. So that's the working service worker.
Nice.
Later we can, this SW prefix is just kind of while getting it working. The idea is potentially to have it just own the entire root path. But I don't know the best way to make sure that the problem with doing that is then it takes over, any of the files that you need to load the page.
Yeah, I remember we were looking at like the rules that the patterns you had set up previously.
So we'll kind of worry about that later, and we can just kind of work with this prefix for now. So anyway, that's the service worker, and the whole point of the service worker is so that we can easily serve files over HTTP from our Wanix environment or from the file system. So for example, if Wanix came with VS Code, that we could have a path where VS Code lives, the static files, and that we could then create an iframe that points to that path, and then you have VS Code in an iframe served, all from Wanix. So
okay.
We'll come.
Pieces are starting to come together a little bit in my head.
Yeah, but the idea though is that it's sort of a programmable thing. It's almost like a little built-in HTTP server. It's as if this domain was a server somewhere. Service worker is almost like the HTTP server, except it's local. And so, like a lot of those, you can set up routes, like a web app. You could be like, oh, when you go to this path, it does this. When you go to this path. And so this service worker framework will probably expose something like that so that you can expose different things, expose different paths that do different things. But anyway, so that's that basic functionality, and I guess that resolves the TinyGo thing. We just had to make sure that library wasn't included. So cool, that is fixed. I made progress on WASI stuff. And then I got to a point where I couldn't really test it without our Linux shell fully working. And right now we have from the Linux shell, we have read access to the file system. Because I've been making this file system adapter. And I realized that potentially it would be easier. Let's see, how does this work? Let's see. Well, you remember the shell that we have working, and we can kind of play with the Wanix file system from that shell.
Yeah.
So I don't have to set that up, but that's, running in v86. And the way we exposed our file system to v86 was through a mechanism, because they have a so 9p is a protocol popularized by Plan 9 that lets you use a file system over the network. Which, in Plan 9 is basically, if everything is done through the file system, you only need this one protocol. You don't need like different protocols for different kinds of things, because it's just like everything's through the file system. But anyway, 9p is used in a lot of like emulators and stuff to share, like whenever you want to mount in a directory from your host into the guest, it's often using 9p because it's such a simple protocol. And v86, although it has a way for you to do networking, where is v86? It's loaded from somewhere. Is it external? Oh yeah. V86 has so when you run Linux, the kernel has support for something called virt.io, which actually, what is a proper virt.io description? It's kind of what I figured. An open interface to allow virtual machines access to host devices. Okay, so it was specifically made for virtual machines. virt.io devices. I kind of imagine them as sort of like virtual PCI cards or something that are put into the device. But so I don't know all what virt.io is normally used to hook into or how it works. But it's a thing that is used to sort of hook into virtual machines. And what v86 set up was a 9p virt.io device. So this means you don't really need networking to use 9p. Instead, there's just like, it looks like a built-in device, I guess. And then I guess Linux has support to mount 9p over a virt.io 9p thing, which makes sense because that's probably a common thing in virtualization. But they implement the virt.io 9p in JavaScript, and most of it, there's all these hex codes and stuff, and so it seems like all of this stuff is about registering. It's almost like creating a device that the virtual machine uses. But then after that basic stuff, build reply, send reply. So it's implementing the 9p protocol, And then there's just a big receive request at the end. I think this is the last method. And it's just a big switch statement based on which 9p message type you get. So it responds to all the 9p messages here. It even kind of names them. And then what they did is, they originally did this to have a virtual file system in JavaScript that could then potentially fetch the contents for a file over HTTP, so that you can kind of stream in a file system over HTTP. And so they use this 9p interface. This 9p interface then mostly talks to a virtual file system that they made. And so this is a copy of that file system. And it's pretty complicated. Like, this is where I was like, oh man, do I need to implement all of this? Like 2,000 lines. And then it turns out, well, it doesn't use all of this. Like, if you look in here, you can see all the methods: create, symlink, get, inode. So I knew to hook into this, I would only need to do a subset of the file system, at least APIs that were defined. I eventually realized that I could subclass the file system. So instead of implementing a file system from scratch, I can kind of use this one as a base and then override things to hook into it. And so that's how the current file system bridge works from Linux. Is it's going over this 9p thing and then talking to this virtual file system, which then I have a bunch of hooks to kind of fetch stuff from Wanix. But it's kind of a wonky architecture because the way this file system is implemented is very much like a normal Linux file system, which is like it all exists it sort of knows all the files up front. Like bridging with Wanix or like even a remote file system, you don't know all the files up front. And so it's just kind of awkward to use this file system that's sort of designed for, I know everything up front, to then kind of load things on demand. So after all of this, I was thinking, well, we could implement a 9p server and then maybe somehow hook it in here so we don't even have to bother with it, with this file system. So we're sort of like removing a whole layer out of this. The idea is, go ahead.
All right. I thought I was following, but what do you mean by removing a layer?
So the virtual machine talks to VirtIO 9p, and then VirtIO 9p talks to this file system, which implements kind of a very Linux-style file system, which isn't actually what Wanix is in a way. It's not meant to be stored on disk. It's sort of a virtual file system. So trying to patch that in to this layer, this file system layer that they've created, feels kind of like a hack. And given how complicated all this is, it's making me wonder if there's a simpler way. So the idea is 9p itself is a protocol for talking to a remote file system. So is there some way we could create a 9p server in Wanix and then just hook it up to this sort of virtual 9p server? which initially would have scared me because I don't know much about VirtIO. But it turns out the way it looks like most of the VirtIO code is totally separate from the part that then handles the 9p request. Like receive request is basically where it handles all the 9p stuff. So in theory, right, receive request, it gets a buff chain, which I don't know exactly what that is, but it seems like some kind of buffer of bytes. Presumably it is the same bytes that you would get over the network using 9p. So, at some point, 9p is a certain protocol, and so at some point the bytes should work with a normal 9p server. So I was thinking if I ripped all of this out, basically, because they're implementing 9p, I have a 9p implementation in Go that can easily expose Wanix. So is there some way I can get these bytes to connect to a Go 9p server that then goes to Wanix directly? And if we do that, then we get rid of all of this code that's implementing 9p again in JavaScript, potentially not fully it's in theory there are things that are missing and I don't know, stuff that's not supported. It wouldn't use any of this virtual file system that doesn't quite fit our needs that we're patching. We wouldn't need any of this either. And in theory, it would solve the write issue. Because right now it's kind of a read-only file system and it has difficulty writing stuff because for every kind of write operation I have to go through and figure out how to make it work in this file system. But if it's just 9p, then I don't have to do that. It just talks almost more directly to Wanix. So
does sound better.
It does. It just seems like a big kind of risky change. So I was putting it off because it's like, well, I know I can kind of keep hacking this. And I don't entirely know if this idea will work of bridging this VirtIO thing with an actual 9p server in Go. But that's something I started over the weekend. But before we get to that, some little other things that were part of the WASI prototype. Worker FS is a little bit more developed in that whenever you start a web worker using the system, it will post in a message that the worker doesn't have to handle, but it can. And if it does, it gets a port to the file system. We just have to wrap it in Wanix FS, we split that off earlier. So it's just the file system. So now in this worker, we can interact with the Wanix file system, which is a big deal. It's kind of the main thing that you want to expose. And then before, we actually had just finished getting a prototype working where we were using shared array buffers to facilitate communication between a worker. Maybe, I don't know if you remember, but the WASI standard, all of its file system operations are not asynchronous. They're all blocking.
Yeah, I do remember a little bit.
Which prevents us from calling anything that is asynchronous, which is pretty much everything. So
Yeah.
how do you call an asynchronous API in a synchronous function? Well, you can run it in a separate thread and then basically have it sit there and spin until it gets a result. Where's an example of that? Oh, I guess I put it all. I kind of abstracted the communication stuff into this value buffer. So this might be familiar. Passing in a shared buffer, and then we created these different views that represent different little segments of that shared memory that we use for different things. Like this control is kind of used to determine, like, okay, this side is done, or when we send a request to the other side, what does that look like? Like we want to get some value. We'd set the control byte, or integer, I guess, to 0. We do a post message to whoever owns this worker thread, and we can use this message to tell them like what data we want to get. And then this atomics wait, I'm pretty sure all it's doing is like sitting here and looping on this control value in our bytes, waiting for it to be something else. So on the other end, we can set this to 1, and then that'll cause this to continue. And then in theory, by then, on the other end, we'd have written data to our shared memory, which we can then access here. So basically, our synchronous code, this is a synchronous function. It's not, there's no promise or anything. We do a post message, but normally you would do something like, you post a message and then maybe it'll post a message back, and you'd handle like on message. But there's no way to get that message that we get sort of as a return value for this function. So instead, we have this shared memory where we can both use the shared memory to sit and spin until there's a response, and then also use the shared memory to get that response.
Okay.
So I don't necessarily like this abstraction, but it kind of made sense. You create a shared buffer in, wherever, a worker. We create that value buffer, passing it the shared buffer, and then we create a new worker that's going to run the synchronous code, and we pass it our shared array buffer. And then in that synchronous thing somewhere in here, when we get the synchronous shared buffer, we create a value buffer here as well. And let's see, is it actually used? Yet? Oh, it's used in these. But value buffer can get bytes. So this is basically saying I want to get some bytes. We pass a message, just kind of saying what we want to get. Okay, sync related, we want to get a file. Here's the name of the file. So that goes. and sets up our shared memory, posts that message to the other end, which is this end. And here we can say, okay, we want to read a file. Here's the name of the file. We can read the file asynchronously. And then when we get the response, we use this value buffer thing and we set the data. And then that will also trigger. So set the data basically encodes the data into the data part of our shared memory. And then I guess this stuff, which I never really used because this is such a edge case JavaScript kind of stuff, but it's doing an atomic operation to change the value of our control bytes. And then notify, I guess this is specifically going to unblock anything that's doing a wait. So anyway, we set the value and then more or less notify this guy to continue. And so that's how, this is all kind of like concurrency stuff, which is very much like not like a beginner programmer thing, but
yeah, nothing I've dealt with.
But the end result is we can run some JavaScript code that's synchronous and still kind of do asynchronous versions of those operations. So before, we also were kind of like setting up WASI manually. There was a bunch of methods that you have to implement, things that will get the arguments, get the environment, file descriptors, stuff like that. But there was a library called Browser WASI Shim that more or less does a lot of that for you and gives some higher level primitives to provide those things. So we can just say new WASI, here are the args, here's the environment, and here are some files or file descriptors that the WASM has access to. And let's see here. By implementing versions of their, they have a file implementation directory. These are all like in-memory things. So they're also implementing a kind of like a file system. And I create my versions of those, kind of extending them and hooking in. Again, it's kind of a weird way to patch in. I'm trying to do like the minimal amount to get it working. But ultimately, it exposes the Wanix file system to this WASM. So I made an example Rust thing.
Rust thing.
Yeah, so Rust. First, we read the root directory. So this program, wherever it is, it's going to read the root directory and list all of the entries for that directory. Then it also tries to read a path here /opfs/file, and then it outputs the contents of that file. So that's all it does right now. But that's like standard Rust stuff. Like these are standard file system operations. And by running this in WASM and WebAssembly, the whole idea is now we can provide a file system instead of it because it's running in an environment where there is no file system. So that gets built. and we put it in here for now. So how does this work? I think creating a WASI worker. Okay. There's probably a recent thing in here too. Yeah. Okay, so we'll create a new web worker. And I made it so that you can start a web worker and pass it a path to the worker that it's going to use. Very similar to how it works in JavaScript. You say new worker and give it a path to some JavaScript. And so I'm pointing it to this. So basically, we're going to run this code in a worker, which itself is going to create a worker. And this worker has access to the Wanix file system. And then it tries to respond to all of the synchronous stuff that the synchronous worker is doing here using the file system. So kind of like a couple of layers going on. That's why this is kind of a difficult thing to get working. So the start WASI worker, that will also it's hard-coded to load this example RS for now. So we'll see what happens. So it ran Rust. It ran a Rust binary. The output right now is just going to the console, so we can see like the output of this Rust program. Found entry. So this is the root file system it sees. Found entry fsys, opfs, proc web. Hey, that's our file system, so it seems to be working.
All right.
And then it even tries to open opfs file.
Sorry, I'm just. Have you tested this before, or are we like, are we just reviewing it now? I assume.
I don't think. Let's see. I got the worker stuff working. We have not seen a WASI process run and access the file system.
Oh, nice.
So this is entirely new since the last stream.
Oh, so, I was wondering, like, if you had tested this on your own, like.
Yeah. So this is not like, oh, I've never seen this before.
That's so cool.
But so we'll probably have to do some other checks, make sure it can write and all this stuff. And I'm not entirely sure how good it is to my approach to patching their stuff. Again, there might be something like the 9p thing where there's a simpler way to hook in. It's funny, they're kind of the same problem. We're just trying to expose our file system API to something else that wants a file system API, but it's using a different way to get it. So it's very similar to the 9p thing, but it's a different like mechanism. So
would you like to take a break?
Yeah, because we're about covering, or that kind of covers everything that was done except for this 9p stuff. Let me quickly go over where we're at here, and then when we come back we can start work on that.
Yeah, sounds good.
So 9p is a protocol. There is a Go implementation of it. There's a few. This is a library that I've been using. It works pretty well. and it's both a client and a server for 9p. It's funny the package is called P9 because you can't start package names with a number. And so this P9 kit library is basically, again, an adapter, kind of like Fuse Kit, where we have our file system abstraction, and then how do we kind of bridge that over 9p. So for example, normally with 9p you get a connection. This gives you a client, and then you can call attach on a path, which then gives you an interface to do operations on the file system. But it's all using the 9p protocol, which is a little weird. So instead, client FS will set up a client, but instead of returning something that you kind of speak 9p, instead it returns what looks like a file system, just like we've been making. So, the file system has create, open, make dir, remove, read dir, could have some other things. Then there's, it returns a file that we can read and write and close. So it's all implementing our file system API, and it's just converting that API to what needs to be done for it to work over 9p. So this way we can get something that looks like a file system, but it's actually a remote 9p file system. Ooh. And then separately, you can create a 9p server. So say we have a file system and we want to expose it over 9p, which is kind of what we want to do with Wanix. We want to take the Wanix file system, expose it over 9p, and then connect it up to the VirtIO 9p thing. So here's our server implementation, which is quite a bit more tricky to do. But the end result is, here's a little integration test that kind of conveys the whole thing. So we created a little virtual file system here. We use our attacher. They call it an attacher because it has an attach method, but this converts the file system to an attacher, which then can be served over 9p. Instead of having 9p listen on a port and wait for open connections, we can give it a single connection. It's interesting that they split it, a read closer and a write closer, instead of just a net connection or a read write closer, but whatever, it doesn't matter. So basically we create a network pipe, which is basically creates two things that look like network connections, but they're just in memory. If you write to one, it receives on the other, if you vice versa. So we give one of those connections to the server to handle, and then the other one we can use for a client connection. So client FS takes a connection, potentially a root attach name, which can be empty, and it gives us a file system. So here we give it the other side of this, and it gives us a file system. And this file system, we should be able to do everything we could do with this file system. So we can do a read dir, and we can see that there would be foo1, foo2, sub. So we check for 3, and the first one is foo1, etc. We could do a bunch of other tests, but basically, it's like we're able to use this file system over 9p almost transparently, because client FS gives us a file system, and then the server side lets us export a file system. And then this lets us test both the client and server stuff, right? Because it's using the client and it's also using our server adapter. And so once this worked, which I just got working last night, it was quite a bit of a pain, but that means that 9p kit, which is its job is to basically convert our file system abstraction to 9p, seems to work. So
nice.
There's one other thing that I'll talk about before we start trying to integrate it with the VirtIO stuff after the break, because introducing a new library like 9p, now we have to make sure it works in WASM and works in TinyGo, and there's actually some problems here. This is not totally resolved. But we can take a break.
Okie dokie. See you in 5.
That's 12:11. Yeah.
Sure.
Okay. BRB. Test, test. Test, test. Okay.
Okay.
Okay. So, the first thing I did to test that this would work as WASM was took the thing that we were building in WASM and just had it not even use it, just instantiate a server because we mostly want to make sure that it can compile. And so let's see, we're using TinyGo. Oh no. Oh no.
Oh. What does that all mean? Where's the real message?
Yeah, what is the first one? Oh, there's even more than... Okay, well that's... Oh, no, that's a different one. Basically, it's all the same stuff. So, I kind of skipped something here. Let me comment this out. So, what I would normally see just trying to use this library is P9 uses this sys package. Stuff at the /x is sort of like, I think of it as like extended standard library. Like this is stuff that isn't quite good enough or ready to go in the standard library.
I did learn about that in the Go class.
Yeah. So they have one called sys, which has a bunch of system-specific stuff, usually involving like syscalls for different platforms like Unix and Linux and all of that. And a lot of libraries like to use it, usually for like constants and stuff. But the problem is it is definitely not made for WASM.
Definitely.
Because it's basically let's see, I do have, I think, P9, here it is. Basically all of the source files in it have specific build tags for different platforms. That's the whole point. So there's no source files that are tagged to work with WASM. So it's like basically looks like an empty directory. So it's like all the build constraints exclude all Go files that were found in here. And so this something in P9 is using something from Unix, but it tries to import it and it's like, there's nothing here for WASM. But I've already run into this, trying to get a network stack working for v86. I got working based on some library that basically gvisor, which Google decided to re-implement of a lot of Linux kernel stuff in Go. as a way to help augment their container security. But what's cool about that is they implemented a whole network stack, like basically what you need to route TCP sockets and da-da-da-da-da. And it turns out if you create an instance of that, you can just wire it up to v86, and then you've got a network for your virtual machine. But it's all virtually defined. You can, one, it can bridge the real network, but you can also sort of create, it's kind of a like a virtual machine is a virtual computer, this is a virtual network. So it's sort of like a virtual switch and everything. So you can even imagine creating like a little LAN in your browser with a couple of, you create like a LAN party even with a bunch of instances of Doom, and they're all connected over a virtual network. Anyway, in order to get this gvisor stuff to work, it also depended on Unix a lot. And so I ended up creating a whole project. It's kind of a hack around this, where, because Go lets you do replace. So, normally you have your packages that you depend on. And this is supposed to be a way to be like, oh, instead of downloading this package, you could point this to a path on your computer. So if you're like working on this package, you can say, use this local checkout that I'm working on instead of, the official one that it'll pull from the repository. But you can also use it to kind of literally replace it with something entirely different. But as long as it has the same APIs, like, it should work fine. So basically I found I could do a replace for sys that points to my own version of sys. And my version of sys does have files that are made for building JavaScript and WASM. And also just kind of lucky that most of the code in this library is generated. So most of, because there's a lot of stuff in here, like, and yeah, most of them are for handling the different platforms, but still a lot of stuff. It's mostly wrapping syscalls, but they had wrote some code that actually generates most of this. So I kind of used a similar approach and wrote some code to generate all the, basically takes Linux as a base and then copies all that stuff over and says, this is WASM.
It's just... So why doesn't that exist already?
Well, because the point of this is that this is supposed to be exposing syscalls and, some like kind of low-level constants and stuff. And the idea is it's kind of set up so that, you get different constants for different platforms. WASM doesn't really have like a syscall equivalent, so it almost doesn't make sense for it to even be in here, except for the fact if I make something that depends on this, I do need to be able to compile it. So this is really kind of a hack, because it's not saying, oh, for all of these things, the JavaScript version will do the thing that it was intended. They're really just stubbing them out. So if you were to call, whatever the method is from a WASM thing, it would basically do nothing. So if you were to do a syscall to, like, I don't know, what's a syscall to don't know, read a directory or whatever. The problem is, or the thing is that most things won't use this to do the actual syscalls. But anyway, the point is to make a version that works in WASM, or at least compiles in WASM. It doesn't have to actually do the things that it's supposed to do because you're in WASM. You don't have syscalls, but we need it to compile. So that's all this is just saying, like, I will create source files that say I will work for WASM, and it's going to have functions in them, but they're not going to do anything. But at least it will compile. Because most of the time, people are using this as a dependency just to get like a constant, you know. So, but, and so one option is, instead of, you know, in a way it's kind of clever to fork that, because then I can easily just do this replace. Obviously, another approach is to fork P9 and make it not use any of this sysunix stuff. Because it turns out that this trick that I got it working for in WASM only seems to work with the Big Go compiler. The Tiny Go compiler gives all of these errors, and I don't quite understand them. I've been working with Claude somewhere. Maybe it's gone, but or no, it was in Cursor. Trying to work this out. Claude doesn't have like an immediate understanding of why it's doing this. Like, looking into it, it's just kind of weird, doesn't make sense. So it could be something that is specific to TinyGo and that we might not be able to do anything about. Which, if
you
that's
really mean that we couldn't do anything?
Well, I mean, it's software. Like, anything within a we could fork TinyGo, and right? Like, you could say that about anything. Like, any software, you can be like, if it's open source, you could have your fork and figure out how to fix it or do something good enough. But in terms of like a long-term sustainable thing, it doesn't seem worth it to fork TinyGo or whatever we might end up having to do there.
Wait, you say fork, but couldn't you just contribute to TinyGo?
Yes. So that's assuming that whatever we do to get this working is the right thing for everybody. Mm-hmm. It's possible that that what we're doing is specific to particular use case. Then if we did, we'd have to like wait for the patch to be accepted, and there might be politics involved, and so a lot of the time I just kind of, unless it's a very clear like, oh, this should be fixed and I know how to fix it, I'm not going to attempt to try and contribute. Unless, we can pay somebody to do it and it's worth it.
So in this case, it's unclear.
It's unclear. It feels unworth it. I don't know what the problem is still yet, but it does have me thinking, well, one way to circumvent this whole thing is maybe to have our own version of P9, because that's a little bit easier to maintain a fork of than like a whole new TinyGo or whatever it would take to fix this stuff.
Does that mean you would have to you'd have to maintain it though? Like, is it still actively being worked on?
That's a good question. And that's a good point. It is mostly not. In a way, this is mostly done software. This package also came from gvisor. So whoever created this just kind of pulled it out of gvisor and made a standalone library. And gvisor was written by Google. And this is a protocol for, well, a particular version of it, but 9p, which isn't really changing. So assuming they got the implementation pretty good, which, I mean, they were Google, and this is in a major thing that is probably pretty good, and it's probably not going to change much. And according to this repository, it looks like, I mean, the main package stuff hasn't changed for 2 years. So it actually feels pretty safe to fork this. Especially if it's just to, comment out some lines or whatever. If there were changes then made upstream in here, fixes that we need, we can still pull those in, but it would be one of those like, now we run into a bug, and it's a bug in this P9 thing, and we look upstream and somebody fixed it or whatever.
Yeah, I guess I was curious, like, as a software developer, how that works. Like, do you do an audit every once in a while, or you just wait till something breaks?
Well, every process is different, large orgs versus me. I guess it has to do with tolerances. For me, though, it's a matter of like, how likely do I think it'll be a problem? Like normally I wouldn't have done this sys WASM fork, but it had just turned out to not be a big deal because it's mostly generated and yada, yada, yada. Had I known it didn't work in TinyGo. I don't know. But anyway, maybe the right thing is to fork P9, especially because I'm not sure that there are too many references to this sys Unix. But we can find out.
Cool.
P9. I was looking for Axis. Actually, if I can see the directories. Okay, so there's not too many instances of it, and all the ones under, I hate this because I want to read it F simple, but it's actually FS implementation. I don't think we use these, so those might be fine. The ones that it's complaining about are internal, which looks like where it's running into here. So no, I'm looking for this stat BSD. So this will only build for BSDs. This looks like, let's see, even though it doesn't have build tags, there are sort of build tags built into the file name. Like if you have a build tag platform name, your file name underscore and then a platform name like Windows or Darwin, it will automatically make that a build tag for that platform. So I guess this is for OpenBSD, even though there's not an actual build tag. which kind of makes me wonder, is this it? Like if you were to compile to WebAssembly, which one would it use? Possibly this one. This is the only one that it just says not Windows. So that would include WASM. And so this possibly is the one place where we're referring to this sys package. So it could be as easy as kind of patching this or giving it an alternative. Let's try internal. So I think the minimum, basically, let's do a stat.js. But I guess it's the old syntax. And then what will stat be? Maybe just an empty struct. Be declared. Well, it doesn't know that. I mean, actually, it could be this. We might have to change this build tag to say not Windows and not JS. That seems to have made it happy. So this is our fork. I forgot where I checked this out though. Okay, temp P9. We can try, instead of doing a replace on, we can place this package with this path so we can at least test it. Go mod tidy. All right, let's see if it will compile now. A little different. Oh. P9 mode internal stat. So I guess now where it's using internal stat t, it's gonna be like, oh, but I need all these fields. Is this, what is happening here? What file is this? Feels like there should be build tags on this, no? Huh. So I guess it assumes whatever platform you're always gonna have something that has these. So shouldn't there be this defines a thing to set up a stat t, but I guess because normally you could do syscall stat t. Although it looks like for Windows, it's a little bit more complicated, but at least they are defining a stat t. So maybe we can basically just use this. Maybe both of these. Look at that, taken from AMD 64 Linux. Maybe I'll say the same thing. good so far. Okay. So that's interesting. It was able to compile. So maybe we fixed it. Like basically we just needed to like add this file. This is an example of something that could be like I would be open to submitting a PR for this. Which would be nice if they did accept, but who knows how responsive they are. They have some open pull requests that are just kind of sitting there. But I guess for now I can make a note to submit PR for P9 fix. For now, I can do this, but of course, this won't work the moment somebody else tries to use this. Although at that point, I could always push this to GitHub, and then the replace would just point to my fork. And it's nice, and it's nice that I can do that because that means people can still build this, and if they ever accept my patch, I would just remove this replace and go back to using the official one.
Mm-hmm.
So I guess even before I submit a PR, I want to create a public repo for P9 fix and drop the local path replace. Okay. In theory, it works in TinyGo WASM. So we could try using it now in our scheme.
Exciting.
Let's see. So, new server. So we need to get bytes into and out of the server for this. Luckily, there is a simple handle method that takes more or less what it would read to get, incoming P9P requests and write the response to. So that's one end of it, and then VD6. We need to figure out where we would do that here. So receive request, buff chain. Really wish I knew what buff chain was.
Surely there's some way to figure out.
Well, we could look maybe at virtq.
We ask AI.
I don't even see virtq. Oh, there it is. Vert IOQs. Maybe. Would AI know? Let's ask. What is buff chain? Yeah, I know that. However, more context. Yeah, it's like asking the same questions I would ask. There's a weird feature because the way this works is like you provide context. So it's like, here are the source files to include with this question. What is buff chain? But you can also do code-based chat, which I guess like it'll go through all your files. I don't know what it, maybe it's doing kind of a RAG style vector search kind of thing. It almost seems like that's maybe what these are, scores. These numbers. So somehow it's doing a search based on this. And then in theory, it's like, okay, maybe these are relevant. And then it looks like it drills down into relevant lines. And then it uses that as context. Based on the code, buff chain is a data structure to use. Yeah. It's first seen there. It serves two purposes. Methods to read data from incoming requests through get next blob. So you can, okay, so it's actually not a single buffer, it's like a chain of buffers or something, but a way to get buffers. Writing replies, it allows sending responses back. Set next blob and push reply. Okay, so you would like receive request, and this is basically what it's doing. So buff chain, buffer, this loads buffer. So presumably this is going to be a buffer of the 9p request bytes. Because it looks like it immediately then parses this buffer based on what looks like, it's not in this file, something that knows how to parse 9p packets. But so in theory, we could take this buffer and then push it into our 9p server, and it should be the same thing as if a client were pushing it in or sending it over the socket. So if we get this buffer, we can just kind of pass this into our 9p server somehow, and then build reply, send reply. The way it sends a response back is using these two. So basically these methods here. So first it does a build reply. So it's gonna marshal those, this reply buffer. Okay, so there's a little buffer that would be the reply. It records the size of it. And then there's send reply, which is using the buff chain. So we set next blob using the reply buffer. So we basically take the reply buffer that it put in here and do set next blob, only using up to the size. Then we push that chain as a reply to the vert queue and flush replies. So yeah, we can get a buffer, then we can process it and then we should get a reply buffer back from our server, whatever it would write to the socket. And then whatever buffer that is, we just have to write it into buff chain and then do this. And then we can basically send error. It's just a different reply. Okay. I guess first thing I'm gonna do is output the buffer. Well, this is also code that has to be built totally separately, and it takes a little bit. So I'm trying to, the easiest thing to do is to get it to call some code outside that's defined somewhere else on the page, like in our Wanix context. Let's see. Vert IO. What would we call it? We could call this receive. I don't know. All right, for now, we do that. And then over here, we have to if window Wanix. Yes, exactly. And I guess we'll return as a, eventually we can just delete all of this stuff, but I'm hesitant to do that just yet. This should effectively do the same thing. It'll just return after it sends the buffer there. So we have to rebuild v86. Oh no, Docker's not running. What's the problem? Oh, update. Who cares about that? So this is kind of the annoying thing, is that making any changes to the JavaScript used for v86, I don't know how to split, because it's sort of built, it has its own build system to create the libv86.js. That's also tied into compiling the WASM and everything. So just to update this JavaScript, we have to go through this whole build process.
Yeah, not great.
I think most of it will be cached in the future, though. Okay, so that's done. I think we can just go into this. So, we'll have to set up a VM, and what else? x86w-tux. I guess I moved it. Where was it loading it before? Huh, maybe I haven't run the VM since I moved stuff around. Okay, so we need our Linux kernel and stuff to be accessible. I guess v86, what is serving this? Huh, I don't even know if we are. Assets. I guess let's look at this. Okay, so we did kind of at least set up. We've got the assets directory and then the v86 directory. Because we embedded that, we could do the same for Linux. Embed these. Files. BZ image. Init RAM FS GZ. Then we can add those. And what else? It's looking in a particular place for it. So we need to update that. Is it in here? Yes. Linux. Okay. Okay. And then VM1. I guess we can just start it, right? VM1. Of course, we didn't wire it up to anything, so we're not seeing the console stuff, but we got our vert IO thing, so that's good. And one of the things that we might have had to figure out is how this wire protocol works, because we might have to like buffer the responses or something. And it would be good to know. Good protocols will do length prefix, so like the first piece of information for a message is how big the message is, which is very convenient, which we can actually see here. So it's like here's a buffer, you know, it's a whole request, it's about 21 bytes long, and the first byte is 21, so we can actually see it is the size. But
nice.
So we want to pipe this into, I don't know if we're gonna have time for this, but
I was gonna say I've got about 5 minutes. Also, someone in the chat said hi, just FYI. I don't know if
Vivix.
you know them.
Hey, I don't remember if I know them, but welcome. welcome back, potentially. Let's see. So we want to create something that we can kind of do this. It takes a read closer and a write closer. We could create some pipes. In A, in B. I'm pretty sure pipe readers have close on them. So this would be in B. Let's see. And then I guess we could do out A, sort of directional. So in theory, if we can get that buffer that we have writing the console, if we can somehow feed that into this pipe, we can basically just write it in. Then it'll be read off this pipe, this end of the pipe, as the input for P9 server. And then it's going to generate some output that it's going to write to out A, which we can read off of out B and then put into a buffer for that thing, something like that.
All right.
I mean, I'm really curious because this could just work. So I might want to go just a little bit longer just to see how this goes. But first I was going to
I will stay till 5 after.
5 after?
And then
Okay.
I'm gonna eat some lunch.
Okay. Let's try standard out. Out B. This is what I want. It's not. It doesn't have read. Oh, is one side? Oh, one's reader, one's writer. Out reader, out writer. If that's the case, out reader, out writer, in reader. Okay, so in writer. So whatever the 9p stuff sends, we should see on standard out, and then we just have to figure out I guess we have Wanix context, so we could do for IO receive. Maybe we can define this context set. Create a function in Go to handle it. Arg0 buffer. Get buffer. arg0. It will already be a uint 8 array. arg0. Copy bytes to go. So buffer is a slice of bytes based on the byte length of the buffer coming in. We copy the bytes to go, so now we have a buffer here. And in theory, we should be able to write buff. Probably check to see if there's an error. Okay, and then we can, that's commented out. We can try building this. And if it doesn't work, then I'll keep working on it off stream. And if it does work, then we ended in a pretty good place. Nothing happened. That doesn't mean it's not happening.
What does it mean?
It means it could be working, but we don't know because we're not in the thing. I can't actually test it. So I need to actually like quickly do web dom new xterm. Shouldn't that have returned? What? What? What is happening?
Huh.
We somehow broke the world. Super. Well, cool. It would have been nice if it just worked, but it never does. What the hell?
So
Okay, well.
You're gonna keep poking at it?
Yeah, I guess so. But I guess for the stream, that's it for today.
Okay. Well, next time we can talk about how you triumphantly solved the problem.
As usual. On Wednesday, I might do a stream tomorrow with a friend to go over to show them Wanix.
Cool.
But otherwise, we got to work on TerraGen. It's all ready to go. Oh well, we'll figure that out.
Yeah.
We'll stream more soon.
Okay.
That's it for today.
All right.
Goodbye, everybody.
Bye-bye.